Imagine waking up to a world where the invisible shield protecting our planet is crumbling. What if the Earth's magnetic field vanished overnight? Compasses would spin out of control, birds would lose their sense of direction, and our technology, the lifeblood of modern civilization, would plunge into chaos. This isn't the plot of a sci-fi thriller, it's a terrifying reality unfolding right now. The Earth's magnetic field is weakening, and the consequences could be catastrophic. What does this mean for our future? How will it impact our lives and our planet? Brace yourself as we uncover the chilling truth behind this silent yet powerful force. Today we dive into the intriguing topic of the Earth's magnetic field and its gradual weakening. The Earth's magnetic field is like an invisible shield, protecting us from the sun's harmful solar radiation and cosmic rays. But over the past 200 years, scientists have observed something alarming. It's weakening at an accelerating rate. Humans have relied on the magnetic field for navigation for centuries. This magnetic force has been our guiding light from ancient mariners to modern-day GPS. But why is it weakening? The movement of molten iron in the planet's core generates the Earth's magnetic field. Changes in this flow can cause fluctuations in the field's strength. Recently, we've noticed a significant decrease, particularly in the South Atlantic Anomaly region. The South Atlantic Anomaly is an area where the magnetic field is fragile, it's growing, and its effects are becoming more pronounced. Satellites passing over this region often experience malfunctions, and even the Hubble Space Telescope avoids this area to prevent damage. But what does this mean for us? The consequences of a weakening magnetic field can be profound and far-reaching. Firstly, we are more exposed to solar radiation without the magnetic field's full strength. Solar flares and coronal mass ejections from the sun release vast amounts of energy and charged particles. Our magnetic field usually deflects these particles, but with a weaker field, more of them can penetrate our atmosphere. This increased exposure can disrupt power grids and communications. We've already seen power outages and satellite malfunctions during intense solar storms. Imagine a future where such disruptions become more frequent and severe, affecting everything from our daily communications to the functioning of critical infrastructure. Moreover, increased solar radiation means higher levels of harmful ultraviolet and cosmic rays reaching the surface. These rays can increase the risk of skin cancer and other health issues. It's not just humans at risk, the entire ecosystem could be affected, impacting crops, wildlife, and marine life. Our reliance on technology makes this even more concerning. GPS systems, aviation, and even financial transactions depend on the stable functioning of satellites and power grids. A compromised magnetic field could lead to cascading failures in these systems, causing widespread disruption. Scientists are actively researching ways to mitigate these risks, from improving the resilience of our power grids to developing better forecasting models for solar storms. Efforts are underway to prepare for a future in which our magnetic shield is less intense than it once was. While these potential scenarios sound daunting, understanding and preparing for them is vital. By studying the weakening magnetic field, we can develop strategies to protect our technology and health and ensure we thrive on this ever-changing planet. One fascinating aspect is that we might see more spectacular auroras as charged particles penetrate deeper into our atmosphere. But this visual treat comes with a price. Increased radiation could damage electronic devices and power systems, leading to blackouts and technological chaos. Imagine a scenario where power grids around the world are constantly under threat. Solar storms, intensified by a weakened magnetic field, can induce electrical currents in power lines, causing transformers and other critical infrastructure to overload and fail. During a significant solar event in 1989, a powerful geomagnetic storm caused a 9-hour blackout in Quebec, Canada, affecting millions. With a weaker magnetic field, the frequency and severity of such events could increase, leading to more widespread and prolonged outages. However, power grids are not the only ones at risk. Electronic devices, from smartphones to complex navigation systems on aeroplanes, could experience malfunctions. Increased radiation can interfere with delicate electronics, leading to data loss, system crashes, and hardware damage. Satellites, which are crucial for communication, weather forecasting, and navigation, are particularly vulnerable. High-energy particles from solar storms can damage their circuits, disrupt their operations, or render them completely inoperative. Reliable communication and navigation systems are vital in aviation. Disruptions caused by increased solar radiation can pose significant risks, potentially grounding flights and causing widespread travel chaos. The financial sector, which relies on secure and timely data transmission, could also be affected. Blackouts and communication breakdowns could disrupt trading, lead to data breaches, and cause significant financial losses. Scientists and engineers are developing more robust systems and protective measures to mitigate these risks. Improved satellite shielding, better grid infrastructure, and advanced forecasting techniques are all part of the efforts to safeguard our technology. While the challenges are significant, understanding the potential impact of a weakening magnetic field allows us to prepare and adapt. By investing in resilience and innovation, we can protect our modern way of life from the disruptions caused by our planet's shifting magnetic shield. There's a theory that the magnetic poles might flip, as they've done many times in Earth's history. This flip could take thousands of years and might have unpredictable effects on life as we know it. Interestingly, ancient rocks and fossils reveal that these flips have happened before. The last significant flip occurred 780,000 years ago. Smaller events have happened. During these flips, the magnetic field doesn't disappear but becomes much weaker and more complex, with multiple poles appearing around the globe. So, while weakening the magnetic field is concerning, it's also a natural part of our planet's dynamic system. Understanding these changes helps us prepare for the future and protect our technology and health. Although the Earth's magnetic field may weaken, our curiosity and innovative spirit remain. By studying these changes, we continue to uncover the incredible story of our planet. Stay tuned for more fascinating insights into the mysteries of our world. Remember to like, subscribe, and hit the bell icon to stay updated with our latest videos.